All right, greetings geometry, I'm back making my next video. If you guys have suggestions on how to make these videos better, this is my second video ever recording something on second video recording something. And I fixed it now, you can see the top of my head. Hopefully you can see the board in here. All right, anything else suggestions that you guys have, let me know. All right, oh, notice, still wearing Under Armour. They did not call me yet. I don't know what the heck's going on. It's been like 5 minutes. I don't know why I haven't gotten a call for my sponsorship. We learned where the formula for area of a kite came from in our last video. This video, we are going to use that formula to find the area of a kite. In addition to that, we're going to have to use something that we learned earlier in the year. Okay? Right triangle stuff. All right, so I'm going to draw a kite here. We're going to find the area of this kite. You'll remember some things about kites. The diagonals are perpendicular. Remember, a lot of these things have to deal with right triangles. When we've got perpendicular diagonals, we've got 4 right triangles in there. Okay? So in this kite, I am going to put 30 degrees down here for the measure of this angle. I'm going to say that this side length is 8. Now, one of you might ask, where did that number come from? I made it up in my head. I made it up. Same thing with that. I made it up. I get to make up the problems because I'm the teacher. You have to solve them because you're the student. All right? This will help you with some of the problems in the packet. I am also going to say that this, and this segment are congruent. Okay. Area unit. Area of a kite from our last video, 1/2 diagonal 1 times diagonal 2. If you don't know where that formula came from and you care, go watch my first video. Subscribe. Let's get like 5 million viewers, and then get me sponsored by Under Armour since I wear it every day. Okay, here we go. Here's our kite. We're going to find the area. We have to find the lengths of the diagonals. I want to use that formula. So I need to know the length of this diagonal and this diagonal. All right. These are both congruent. Got a right angle right here. Right triangle, 2 congruent sides. Right, it's a 45-45 special right triangle. In a 45-45 special right triangle, I have given you the hypotenuse. The hypotenuse is 8. If the hypotenuse is 8, what are the legs? It's been a long time, a few weeks off. How do we find the legs in a 45-45 90 triangle? X, 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 rad 2. So if this was 8, how do we get from here to here? Divide by, well, we got to get rid of that rad 2. But remember, you divide by the rad 2, you have to rationalize the denominator. We did all this. I don't have time in this video to teach all that again. I can go over it if you have questions. Okay? But after doing all that stuff, we can set up similar triangles. We can do my Pythagorean theorem, but we can figure out that this length is 8 divided by, I guess I'm doing it anyway, 8 divided by rad 2. To get from there to there, you divide by rad 2. 8 divided by rad 2, but you got to rationalize the denominator, rad 2 over rad 2. You get 8 rad 2 over 2, which is equal to 4 rad 2. Okay? 4 rad 2 is the length of that segment and that segment. So if this is 4 rad 2, this is also 4 rad 2. The entire length of this diagonal right there is 8 rad 2. Right, okay, area equals 1/2 of 8 rad 2. Now we need to find the length of the other diagonal. This is also 4 rad 2. So I've got one little piece of that diagonal. We now need to find this. What type of triangle do we have here? right triangle, 30, right triangle, 36, 30, 60, 90 right triangles, 2 triangles, 30, 60, 90, 45, 45, 90. Good thing Mr. Sokolowski taught me how to solve those problems so awesomely domination style in that unit, because I know if this is 4 rad 2, all I need to do is multiply by rad 3 to get to there, and I know this is 4 rad 6. You don't remember? Oh. This is 30 degrees. This is x. X rad 3 to x. To get from the small leg to the big leg, you multiply by rad 3. 4 rad 2 times rad 3 is 4 rad 6. So this is 4 rad 6, and this is 4 rad 2. So our other diagonal is 4 rad 6 plus 4 rad 2. Can you see it? Oh no, you can't see it through my back. Wow, this is some ugliness going on up here. Ugliness. That's all right. Just deal with radicals. Radicals are just like variables. That could be an x, that can be a y. Who cares? Multiply. Area equals half of 8 is 4. 4 rad 2 times 4 rad 6 plus 4 rad 2. Now distribute. 4 times 4 is 16. Rad 2 times rad 6 is rad 12. 4 times 4 is 16. Rad 2 times rad 2 is rad 4. Well, let's just write it down. It's rad 4, which is 2. We'll get to there. Okay? So basically, this is just 16 times 2, which is 32. Whoops. Someone into the class right now would have raised their hand like, oh, that's supposed to be a minus sign, a plus sign. No, I know, I fixed it. There's your plus sign. All right, what's wrong with this? All right, we have to, it's not simplified. 4 goes into 12. So this is 16 rad 4 rad 3. 4 times 3 is 12. The square root of 4 is 2. 2 times 16 is 32. So we get 32 rad 3 plus 32 as the area of our kite. What happens at the end? Does that mean I just stop the video? 7 minutes and 50 seconds. Why does it seem like it takes so much longer when I do it like on the video camera? And am I looking in the right spot? Where am I supposed to look? Am I making good eye contact?